All right, what should be on your desk right this second? Homework number 3. What else should be up?
Pen.
What should be hidden? Me personally, I would be annoyed by something stapled in the books that I won't have, but I'm just saying to save you time, you could just staple at the top 2 edges and then it'll be alright.
So if we did it front to back and then like put it in front of it, we just like staple it and
And then if for any reason you have to have paper that's bigger than your spiral, you need to go ahead and trim that, otherwise it's just going to be awful for you. Do you guys do that, by the way, real quick, logistic? If for any reason you forgot to spiral, he's choosing to copy in, and that's exactly what I would do as well, same thing. But if you ever did forget, you could go ahead and just put 2 staples at the top. That way I could see what the homework is, and then you're good to go. Does that make sense? There's never an excuse if I forgot my spiral, so I shouldn't do homework. That's not good enough. But you guys hopefully get used to always taking home your Precalc spiral and notes whenever your homework, which is always except for the day of the test. Yeah, that way you just have everything on ready to go. All right, cool kids. Happy Monday, happy new week. Since it is chapel day, time is a little short. We're thankful for chapel, but we do kind of have to get going real fast on chapel days. So, homework number 3, section 1.3. Let's go ahead and go grade. I think there's only like 3 evens, 3, 4. There's not many. Yeah, I can actually fit them all on the screen. So let me give you guys a second to go ahead and grade. I'm not gonna have you guys do like your collaboration today. Collaboration is hard work sometimes. Some days any work is hard work. If after grading your evens, you have any questions, evens or odds, go ahead and raise your hand. This is a nice one to have over a week. It wasn't meant to be too bad.
for number 10, we were just pairing L3, L1, and
Yeah.
L.
So A should have been L2. The book always just gives explanation. It's part of their like solution. But I don't think it actually said just one. So yeah, L2, L1, then L3. Hopefully this is very helpful. Number 56, what equation, what type or form of equation was the best one to use? So, yeah. Some of you, I know you like slope intercept, but I promise point slope is more helpful in the long run. Because how often do you actually have an intercept? And you can just plug in and simplify. So if I were you, please, please, please don't be scared of point slope. Alright, any questions about evens or odds? You guys should be close to finishing it up. I'm going to leave this on the screen for like 2 more seconds. I'm actually going to pull up Calc Chat. So I want to kind of make a point to you guys that even though Calc Chat has solutions, once again, it's not always the best solution or the most detailed. They don't always explain their work. So let me pull it up really quickly as I pull up the problem. Okay, we're going to go ahead and transition away from answers. You guys should have had them by now. There was not much to write. Meaning, remember, the first thing you're supposed to do is check the answers. So, number 4 was like a 1 word. Number 10 was like a L2, L1, L3. Doesn't take too long. And then the last one was a quick sketch. And the final equation. If you were writing down the work, you missed something in homework. Number 1 and 9, let me go ahead and freeze the screen on this one so you guys can reorient yourself with the question. You should have a summary in your homework, right? It shouldn't be brand new. I'm also pointing at Calc Chat just so we can see what it did have. How many lines, as you guys are reading, how many lines were you actually supposed to graph? Total. 2 pairs, 2 sets, but in each set, how many actual lines were you supposed to graph? 4. So you're supposed to graph 8 total. 4 in the first set, 4 in the second set. And what were you technically asking? Compare and contrast. Let's compare. What's the same? What's the same in both questions that you were asked to analyze? Fastest, that's one way of putting it.
Change.
Most quickly, there is change happening. Okay, contrast. What's the difference between the first question and second question? One says rises, one says falls. How does that correspond with slope? Don't we have positive and negative slope? Don't we have uphills and downhills? Okay, but the comparison, what was the same, was that both of them were talking about most quickly. How did you guys correspond most quickly with the graphs themselves? Can anybody just, I don't know, off the top of their head, or if they can remember how they looked at the graphs most quickly, what were you actually looking for? Chris? Well, there weren't any curves, though, because these are all lines. How does that quickest look? Steep. How steep is it? So the more quickly, if you just think about if you were going downhill, you're going to be going downhill faster when the slope is steeper. So if you're looking for the steepest downhill, what do you think you're looking for uphill? Steepest as well. It's just rising most quickly. So you were looking for the steepest in both parts. This was in section 3, right, guys? And then number 109? Okay. Now, according to CalcChat, let's go ahead and figure out what they showed. Oops, it froze again. Sorry. And let's see if I can zoom in a little bit, maybe. There we go. All right. So what's the first picture? It's the first group of 4 equations, right? So the first picture is the first grouping of 4 equations. So we have our 0.5 being the, how would you guys describe it? In comparison to the rest? The flattest or the least steep, right? It's the flattest. And then, as we went to 2, what happened? Oh, sorry, 1. I missed 1. 1 got a little bit steeper. 2 got a little bit steeper. And then what's the steepest? 4x. That's the answer. Which one was, or where, or when was it rising the most quickest? When m was, or when slope was 4. Then what's the next set of pictures? Yeah, the negative one. So we had all negative slopes. And then look at negative 0.5. That's downhill. That's not very steep, right? What's going on at negative 1? Steeper. Steeper. And then what's the steepest? Negative 4. So the steepest positive slope, or rising most quickly, was 4. Falling most quickly, or the steepest in the negative direction, was negative 4. So then they were asking me to go ahead and interpret, right? Now, they put it in a very snazzy way that most of you probably wouldn't off the top of your head have thought of. If I read all of yours when I check in at the end of the chapter, and if I read the word magnitude, I'll be like, oh yeah, sure, that was very original. But the greater the magnitude of the slope, absolute value of the slope, the faster the line rises or falls. Did anybody put something that they think it works just as well as far as describing how to figure out what slope is the steepest, or when you'll be rising or falling the fastest?
The bigger the number is, the faster it falls around.
I like that. The bigger the number is, but you might want to throw in the bigger the absolute value around number, just because technically negative 4 is lower on the number line than negative 2. So I like what you're saying. I would put absolute value around the number. That's just the bars. That's totally fine. What else?
But the slope becomes steeper as the value increases, or decreases when under 0.
Good. That's perfect. That's a great way of describing it. So if you're in positive numbers, as the number increases, goes to the right, the slope gets steeper. If you're on the negative numbers, they behave oppositely in the sense that as you go to the left, it gets steeper. Do you have another one?
Yeah, I didn't mention negatives though. The higher the slope, the quicker it rises.
Okay, that's a good just comparison of slope goes together with rising quickly, right? So the steeper the slope or the higher the slope, yeah, I agree with that. And then if you were to go negative, you could say the lower, the steeper in the negative direction. You probably have to put something in there like that. Exactly, yeah. Great, exactly. Great comparison of slope with rates. All right, cool kids. I'm going to go and get out of calc chat. I think that answers our number 109 question. Let's go ahead and get out of homework number 3. That one didn't take too long, right, guys? Michael. Use the one that's not shiny. It works better. Why don't you just bring your notebook back? It'll probably be easier. It's okay. All right, cool kids. You know what to do. Composition book. Your section is ready. I have openers on. Guys, we can make this transition super fast. It can be hard. It can be closed one book, open another. Theoretically, we both should have been on our desk when we go. Usually, we don't have an opener on the days that homework are due. Homeworks are due. Because we're just checking real fast. Because we want to get to questions and have time if you guys have them. Maybe we only have one. You can imagine in some homeworks, like in homework number 2, there's quite a few questions. There were quite a few. I've done this before, I apologize. Section 1.4, quick warning. Remember, you guys can look on the blackboard, right? This homework is not due until Wednesday, which means procrastinate. No, which means homework tonight is what? Start. And I'm warning you, unlike section 3, section 4, you really want to start now. Section 3, we only have one night. I'm just saying, we're taking 2 days for a reason, okay? So if 2 days is for a reason, then we want to start. We want to start it. So hopefully homework 3 was pretty easy, so you're not behind on it. You're able to be like, hey, I'm caught up. This is good. I can start coordinating. If you ever have extra time after copy, and say if you went straight to the table of contents, that's good. Now, as you guys are writing, if you want to hear some of where we're going in section 1.4, we're going to have to go a little bit into word problems. Trying to deal with functions. Functions have independent and independent variables. We're going to use word problems to get a better sense of which is which. Sometimes we call them X and Y, sometimes we don't. So we use word problems to illustrate that. But then we're also going to things like domain and range. We're also going to things like function notation. F of x minus 1, how do you do that given a function? Maybe even compositions, f of g of 2x. So that's just a little preview of where we're going, okay? Thanks, guys. You've heard relation and function since, I don't know, what do you guys think? Middle school? Maybe even elementary? Probably not elementary. Probably middle school. Remember relation, the key is relation is any set. Somehow just two quantities are related. You can think about time and distance. That's a common one. As time passes, if you're moving, if you're in motion, and your distance is changing. You can think about, what's another one? Temperature and time. You could think about like a Starbucks Frappuccino sitting in the sun this week. What's going to happen to that temperature in that Frappuccino? Yeah, as time passes, that poor little Frappuccino is going to just be a puddle of lukewarm something, right? So you can think of time and temperature being related. You can think about, let's see, what's another one that you guys have seen recently? Population and time. Oh man, time's in everything, huh? Today you'll see something where you have volume and radius. Depending on how big the radius is, your volume's going to change of the cylinder. So just two quantities that are somehow related. One affects the other. A special type of relation, right? A special type of relation where each x is paired with one and only one y. You guys graphically would have thought about it as the vertical line test, right? I'm sure you've heard that one before. That doesn't always work if you don't have a graph. Wow, I gave way too much room for that. Just put that in the middle. Vertical line test. If you have a graph, that's a great test. But if you don't have a graph, that can be a little bit confusing. And some of you also forget what vertical lines are. How do you get vertical lines? It's not y equals mx plus b because those are like diagonal lines. How do you get a vertical line? X equals. I heard it from some. Some of you guys think y equals. That's going to be an x equals number. X equals a constant. Just a quick reminder as we go. On the next page, I do have some examples though, and some of them are going to use words. Well, let me show you. Three different examples. Oh, 10 to C is where it's supposed to be. I'm not sure why it's chilling over there. Here we go. Let's see. If you guys want to leave off letter A and not write that one down, that's okay. Just write down B and C. A is just giving you an idea that technically there can be data given to you in words, but you're not going to need to study about representatives and senators in the U.S. government. But maybe some of my history buffs, or at least government buffs, who can help us out a little bit today. In just a moment, we're going to actually probably work backwards. Most of us do best on the graph. Maybe just a few will do best in a table. And A will probably be the weakest for all of us. For letter C, the fact that the graph is what we would call mathematically discrete, aka it's just points, it's not connected. It's not going to affect at all the answer that we're going to give. Just because it's just points, that's not going to affect the answer that we're going to give at all. It could have been connected or it could just be the points. Either way, in this one, the answer is going to remain the same. You guys almost have it. Go ahead and check out letter C first. Check out letter C first. In just a second, I'm going to have you guys vote with a thumbs up if you think it's a function. And if you don't vote, I'm assuming that you say it's not. In just a second, I'm going to have you vote on C, vote on B. A, we better talk it out because half, 3/4, 5, 6, 9, 10 of us don't know exactly how to think about letter A. And letter C. Quick thumbs up if you think it is. Is it or is it not? If it's not, just don't do anything. If it is, put a thumbs up. Okay, so many people with the thumbs up. Who hasn't won? Michael, what do you think? Why is it a function? Yeah. If we were to, remember, vertical tick marks on the x. If x equaled -2, how many points would it hit at? Just one. If x equaled -1, remember vertical line. Just 1. X equals 0. Just 1. X equals 1. Just 1. X equals 2. Just 1. Whatever x's are displayed only have one point that goes with, so yeah, it's a function. Good job. Abbreviation. FN is a common word for function. Guess if you could do FNCTN, that's kind of awkward. For letter B, I think you need your calculator abbreviates function with that one. Letter B, real quick, let's vote again. Thumbs up. And on this one, thumbs up. Oh, we'll keep it the same. Thumbs up if you think it is, nothing if you think it's not. Smarty pants. It's a no. Everyone pretty much agreed. Or you just followed the people around you. But either way. Who has a reason why?
You can't have the same X value.
And so these ones are all good, right? 3 goes with 8, 4 goes with 5, 5 goes with 1. But the problem about 2 is where does it go? 11 and 10. That's not good. That makes it fail. That's a relation, but not a function. Because if you were to graph each of these points, which you could do if it helps you visualize, you would have to go over to 2 for the x. And you'd have to go up to, well, let's just go by 2, 4, 6, 10, there we go. It would have a point at not only 10, but also 11. It would fail the vertical line test. X equals 2 would go through 2 different points. So that's a no. Letter A, I need somebody that knows politics, at least a little bit. How many representatives does every state have? Every state? Ah, how many senators does every state have? Okay, so that one's constant. Number of senators, every single state has 2. What's the dilemma about the representatives, and why were some people like, not every state? It's based on population. So, what are some examples of representatives? Well, let's not go into all the different states and how many representatives there are, but let's just say there are many different X's, but question, can different states have maybe the same, based on population, the same number of representatives? Does that ever happen? Yeah. Is that a problem that happens? If you were to make a table, you would have all the different possible representatives from all the different states. Some of those states might have the exact same number of representatives. Why is it going to or not going to be a problem? Why would it not be a function? Okay, you can't have the same x twice, but problem. That's not all that it says. You can't have the same x twice with different y's. What are all the y's? So if you have the same number of representatives, you will have repeated x's, but what's the entire y column? 2. So do we have any x's paired with different y's? Yeah. Tricky, tricky, tricky. It is a function. Because if I was to show the table, which to be honest, I don't have all the representatives from all the different states memorized, so I'm not giving all the different X's. But I do know 4 senators, right? They're all going to be 2. For the representatives, does any state only just have 1? That's not a thing.
I think Rhode Island has 1.
Rhode Island only has 1? I'm sure somebody has 2. Let's just pretend a few people have 2. And let's put like 5. I'm just making up numbers. I'm not a government teacher. Go ask Miss Zuckerman. Anyway, is this a problem?
No.
No. Because each X goes with only one Y. It's not 2, 3, 5. It's not 2, 10, 12. It's not 2, 3, 2. Each X, even though it's repeated, still only has one Y. So if we were to graph this, what would we graph on that place, and why does it pass the vertical line test? You would have a 2, you would have another 2, and you would have another 2. The question is there still only 1 point? Yes.
Oh my god.
Each X paired with only one. What's the one Y? 2. Any other Y? No, just 2. Are you sure? Mm-hmm. Just 2. Alright, let's keep going. You just saw me represent, well, you didn't see number 4, but you saw the other ones represented. Represented. On the examples on the page before. Without doing some huge long explanation of each of these. Think about, remember how I have you shorten things in your homework, especially with definitions? Verbally, what are we using to describe the math? Like letter A, right? We're using words. Somehow we're trying to describe some situation, some scenario, one quantity with respect to another with words. Numerically, do you remember from the vocab in your homework? What do you use with numerically or numerical? Points. And usually in points we put them in tables. So we'll say tables, but it could just be points. You're right. It could just be data, values like ordered pairs. We could give you ordered pairs, or they could give you. What else would they give us? Ordered pairs, tables. Yeah, but that'd be graphically. No, you're right. For numerically, I think as soon as you make a scatter plot, you can see the numerical data, but you're in a graph, so you're thinking about it, analyzing it graphically. I think most statistical studies, though, they could just give you lists of numbers, but that'd still be a table, though. Lists, tables. Anyway, algebraically, what are you given? Equations. Exactly, equations. I'm not going to say functions, because remember, not all equations are functions. Does anybody have one that we've actually written in our notes and worked with in our homework that is not a function? But yet you still studied or wrote down and need to study the equation? That's a line, that's a function. But it is an equation that we've worked with. Equations is lines. What's some other equation we've written in our notes thus far this year? Standard form of, nope, still a line. Circle, yeah. Circle. Think about it, that totally fails. That fails like everywhere in the circle. All the vertical lines are going to fail because there's going to be 2 on each. But it doesn't matter, it only needs to fail once to fail completely. So yeah, a circle is not a function. How does that equation look? X is squared, but who else is squared? Y is squared. There's our problem. All functions can be written y equals. All functions you can get y alone, which is why, hey, help out. Don't we have that whole y equals menu in our calculator? Can you guys go to mode real quick? Just giving you a precursor. We're not having to deal with any other mode than what you're currently in for one. But we are going to see all 4 modes that have to do with what I'm talking about. So you guys figure out what menu you would need to change in that mode. There's lots of different options. Which one you would need to change to make it so that when you hit the y equals button, it would be something else. Function. Function. Right now it's func, right?
It's funky.
F-U-N-C? If you change that, what's the one that's right next to it?
Parametric.
Par, parametric, good. Change it to par and go hit the y equals. Does it look different? Oh, that's exciting.
This is fine.
Go back to mode and go down and change it to pole for polar. Pole for polar. And hit your y equals again.
Love it.
You guys can try and hit the X button too if you really want to have fun.
Oh, it's a weird.
It's a theta. Isn't that next to the X and then go try sequential, SEQ. Hit y equals and hit your variable button, SEQ. That one's Are you guys seeing why there's an X comma T comma theta comma N on that variable button?
Yes.
You only have X's showing up when you're in what mode? Function. And there's only y equals when you're in what mode? Function. Interesting. Okay, get back to function or else you're going to totally trip yourself out next time you go to graph something. So go to function, get back to your y equals looking normal, and everything will be better. Calculators down and not out but off. Okay, we could go back and actually label, but guys, you know that A is words, B is tables. So A is verbally, B is numerically, C is graphically, yeah? Cool. Let's keep going. Our goal is to get through the word problems. Let's see if we can. Let's get through this page. We have a word problem on the next page. I'm going to help you summarize it in your notes, because the same way I want you to summarize in your notes, I want you to summarize for homework. Therefore, I don't want you writing every word. That's going to take way too long. So I'll try to help you as you write the next example in your notes to be like, hey, shorten it by only writing this, to also show you what to do in your homework. Yes, that over is really awkwardly placed. I apologize. You only need to skip one line in this space that's a little bit bigger than the rest. Otherwise, you can write them just one line after another. That's close. You only need to skip one line right here in the very, very middle where there's extra space. So give you a second, that way you can tune in when I start describing some of them. Different pieces. And the reason why I have to have this page before the word problems on the next page is because even though it's hard to remember, you guys are used to seeing X and Y. But as soon as something gets put in the Y spot, like volume, as soon as something gets put in the X spot, like time, my brain's a little confused. A little confused. A little perplexed. So as you guys are writing, I'm going to go ahead and put in, even though you know that Y is a variable and X is a variable, I know you know that. I need you guys to think about these as open spots, open blanks, open boxes, where not only a Y has to go in, where not only an X has to go in, where some other quantity, some other variable, some other representation can be put, can be placed. But any of you guys have ever taken any Common Core math classes? Maybe you came from a public school or private school trying to do Common Core. Common Core has good and bad to it. The idea behind it is awesome. I think almost every math teacher would say the idea behind it is good. The application is rough. Common Core says we're teaching too much of how to do the math and not how to understand it. How to do it and not understand where it comes from. So what it's trying to do is have students interacting with the why and not just the what. It's a good idea. Anyway. With all of that, there's been a lot of talk recently, and not even recently, about maybe the way that we taught originally functions and the way that we taught X and Y's might be a little bit off. Because some would say that we should have never taught students X and Y variables before teaching the idea of input and output. Some say we should totally not even introduce variables until we teach the idea of input and output. Put something in, you get something out. We're not going to like basic life philosophy of you put in to get out. That's not exactly what we're supposed to be doing. But it's like totally anti-scripture. But anyway, coming back. But input, output, that has to do a lot with computer programming, right? Input is what like the user would input, output is what the computer's going to do. So if any of you guys are like coding or like programming. There's a lot, I know we don't have an AP Comp Sci class on campus, but there's a lot you can learn online as far as with coding, with programming. It's a super hot topic these days. You can learn a lot independently, and we are trying to get an AP Comp Sci class back. I know the gaming class Mrs. Christensen does. It's fairly basic-ish, but if you dig deeper into the coding and the programming, you can have a lot of fun with that class. Anyway, just a couple STEM little things in programming. So input, output. Who would be the input between X and Y? Coming from your years of experience with math and dealing with X and Y, who would be the input? X. X would be the input. So I'm going to say this little box on this side and all of these different wordings, all of these different ways of describing two quantities and how they relate to each other. And not even how they relate as far as like the function and the numbers and the addition and the multiplication, not that kind of relating, just that, hey, this one depends on who? Depends on the other. The input goes along with the independent variable. The input goes along with the independent variable. The input goes along with the independent variable. You're given this. Too bad, so sad. Deal with it. You're given this. You need your computer program to take whatever the user gives. Now, sometimes the user can be really, really dumb, as we often do. But sometimes the user can get something that's really, really dumb, and it's like, what am I supposed to do with this? And then computer errors happen, like your calculator. Do errors happen when you have the window go from x min 10 to x max negative 10? Why? Because the calculator is programmed to say, no, the user knows what to do. So the minimum should be the lower number. The maximum should be the higher number. Why does the coding break down? Because it's like, user, you have some issues going on in what you're putting in my program, right? So sometimes the input is bad input. But as long as the input is valid, right, it's independent, whatever, you're given that. Now you have to, the program has to deal with what's going to happen as a result. That's the output. The output is the y. Now I know, I'm relating this to computer programming, and some of you are like, that is not my brain at all. I'm just letting you know. Input, putting in, output, getting out. And you guys can think of input plugging in, right? Don't you usually plug in for functions? Don't you usually plug in x's, simplify, and get out a y? Same thing. So, independent variable is x, dependent variable is y. Depending on what is given. Depending on what is given, y will change. Depending on what is given, y will change. Just a few different ways of thinking about input and output. And just trying to get you guys used to, or at least ready for, what if they don't give us a y and we're not supposed to use a y? What if they don't give us an x, we're not supposed to use an x? What if they give us something else? What if they give us a measurement? What if they give us a different variable? Do we know how to deal with things if x and y are not present, but quantities representing them are? Like this example. Now pause, time out. You have to write every single word. No, let's model this. Okay, long story short, right away, what can you say this problem is? Iced tea. You make it the iced tea problem, right? In homework, don't they almost always put a little title as to the word problem? Like football field, or I don't know. So right away, it's an iced tea problem, true? Okay, iced tea problem. What is the the main idea? The main idea, the long story short of the problem. We're in marketing department, soft drink company, experimental food can, iced tea. Iced tea, but like colon, new can, slightly narrower, taller than standard. Okay, that summarizes the first one. Or we could say something about new can for iced tea, slightly narrower, taller than standard. And the only other most important piece, besides talking about the new can for the iced tea, putting it in context, slightly narrower and taller than standard, is this one right here. Now, for those of you that hate writing so many words, you should want to do what I want you to do for this last one. And this last one, you can give me the words, but I need you to write that into a math statement. Kiddos, how do we do ratio in math? You can do H colon R, you can do H with the word to R, or the most common one, and you can do H over R is 4. And some of you see that in the picture over here. You can do H over R is 4. I want you to figure out, looking at letter A, what are we missing that wasn't given to us in the title, and yet we need to be able to write any sort of equation function? Well, okay, we need numbers, but they're actually asking us to find a formula, like to write a formula. So we're keeping the variables. We're going to have an H in there, we're going to have an R in there, volume, we're going to have a V in there. But what shape is this? Sometimes in math it says, you know what, you should know this, and if not, you should know how to find this. What's the volume of a cylinder? Area of the base, what's area of the circle? Pi r squared. Area of the base times the height. So, when they say write the volume in the can as a function of the radius, what they're saying is there any way to get V equals an expression with only R's? We're going to pick up here tomorrow as we talk about function notation, what it means to have an equation only in terms of one variable. Okay, so I'm not saying you get super far in homework, you get in until you get stuck and be like, please come back tomorrow and figure out what's going on. Sound good? Cool deal, guys. Very nice of you to catch up. Please go ahead and do so tonight. Is the best time the entire week to catch up on anything you're behind on. I'll see you guys later. You guys are involved a while ago. Stop playing. Now you're going to get back a lot of stuff and do your calculator quizzes. So maybe that'll motivate you to not fall behind.
The hardest language that was so cool. Really?
Yeah, I don't know.
What?
Remember?
Yeah. Travis made some tea. It was terrible. Made that up.
There's a duck standing across the road. All of a sudden, the chicken sets his duck with
Wait. Say that again.
There was a duck staring across the road. He looked across it. The chicken comes up and says,
Hey,
"You see Seeger swing?
what? No.
Swing out of the